Supplemental math videos from Circle Christian School. Expand and condense logarithms. Remember simplifying those exponents? Well, it's the same thing, and because logarithms are an inverse of exponents, it just stands to reason that we would expand and condense to simplify or get big, then make it small. To expand and condense, we still need to understand what a logarithm is. So if you had log 2 8 equals 3, remember that the 2 is the base, 3 is the power, and 8 is what base 2 power 3 equals. So it's just this backwards thing. Everything's just in a different place. Expanding and condensing allows for evaluating without a calculator, as it did in the old days. And like anything, there's just rules to follow. Exponent-like rules. So let's just compare the exponent rules with the logarithm rules. The product rule says same base to a power times same base to a power. We just add the powers together. Well, we have the base A right here, and what we're going to do is take log base A, U, and we're going to add it to log base A, V. Recognizing that here is this power right there, the power of m. And this logarithm right here gives us the power of n. It equals an exponent. So because we took the powers and added together, we're just going to add the logarithms together. Quotient rule says same base to the power of n over same base to the power of n. We're going to subtract them. So log base A, U, minus log A base V, because this logarithm here represents the power of m, and this logarithm here represents this power of n, and what we did is we subtracted the powers. See how just backwards this is? Okay, the power rule says base A to a power of m, then powered up to a power of n. We're going to multiply the powers together. So this is going to give us log base A, U, and we're going to take that n, that power here, and multiply it. Which just goes to say that this log A base U is the a to the power of n being multiplied to the power of n. And there you go. It's just backwards. Great to note that if you have a logarithm where their u and the v's, or the two numbers, are being added inside the parentheses, it does not mean the same thing. That means something totally different, so you can't multiply it together because A, same base to the power of n, plus A to the power of n cannot be added together. It's all about multiplication. Think about it for a minute, and I think you'll see the pattern. Alrighty, let's do a little bit of expanding here. Alright. So what we have to do is figure out just which one of the expansion rules for logarithms that we're going to use. Remember, ln is just the same thing as log. It's just that we're dealing with the natural base e. Well, division is happening between the top number and the bottom here. So we're going to go to that logarithm rule 2, and it's going to equal ln 2 minus ln 3, because if we have any type of division going on, it's a minus sign. Next one, we have between the 7 and the x here, multiplication. So we have log 10, 7, plus log 10 x, because if we have multiplication, we're going to add the logs. Now, the next one here has several things going on. We have some multiplication, we have some powers, and we have some division. So we have a chance here to actually use all three rules. Well, what goes first? What goes second? What goes third? Well, just like you read is going to tell you who goes first, second, and third. And I read log base 6, the 8 times the x to the power of 3, all being, so I'm going to go log 6, base 6, 8 plus log 6 x, and I'm going to take that power of 3 and throw it out in front of the logarithm there. And then I'm going to go minus my log 6y. Okay, now it is possible that because the top part was done first, that you can put this inside parentheses if you like. It's not always mandatory. Condensing is just taking something that's been expanded and bringing it back. And you just have to think of which one of the logarithm rules it entailed. Because we have a minus sign, I know I've got some sort of division going on. So we just take ln, see we only need one of these guys, we don't need two of them. And then the first guy over the second guy, x over 3. All right, the next one here, we see that we've got something on the outside. So there was a power thing. We have a plus sign. So there's this power plus sign, rule 3, and then rule 1 kind of thing. So I'm just going to make the log 3. Only need one of those because it's the numbers and things happening to the logarithm within the 3 rules that have to be put together. I have an x, and I have a times 5, and the x had a power of 1/2, and in some cases you can leave it like this. It's not very proper, but we can leave it like this. So I have log 3, oops, I have a log 3, log base 3, and I'm going to put the 5 first because that just is a little bit more of what we see as a common. And remembering that fraction exponents was some sort of radical. Remember, there's some times where radicals work better than exponential form. So our final answer is going to be log 3, 5, and 1/2 is the same thing as a square and an x. Inside power over outside index. Okay, the last one, you'll notice you got some parenthesis things on. So I'm going to do the stuff inside the parentheses first. So we have ln, and we have a 4 times the x. Very good. And that was what was inside the parentheses. So I'm going to put parentheses around them. And we had a number on the outside here, which was a power. So we have to bring the power back. When you have real numbers, you're going to have to do real math. Remember that the 3 on the outside here is saying power up the parentheses. And that equals ln 4 times 4 times 4, number to number, 64. X times x times x, x to the 3rd. And anytime you have to evaluate, they'll tell you what either a certain log base equals, or what ln equals, or what e equals, or any of those things, and you just plug it back in, do the calculator magic, and give it a value.